You know the feeling. You're stuck in traffic, just watching the minutes of your life tick by. It's a universal frustration, right? But what if the answer isn't just building more roads? What if the solution is artificial intelligence, and it's already here working on our streets right now? Today, we're going to look at how AI is jumping out of the research lab and onto the pavement to fix the gridlock we all despise. I mean, this scene is just way too familiar, isn't it? It's this chaotic, complex dance of cars, buses, motorcycles, everyone just trying to get somewhere. And this daily grind, it's not just annoying. It wastes our time, it burns fuel, and it pollutes the air. It's a problem that feels as old as the automobile itself. And that really gets to the heart of it. We live in this age of smart everything. And yet, the technology running our intersections often feels like it's totally stuck in the last century. So why are our traffic lights so far behind? Well, the simple truth is, for the most part, they are. So in this explainer, we're going to break it all down. First, we'll look at why those fixed-time signals are such a problem. Then, we'll introduce the AI that's like a co-pilot for our roads. We'll get into exactly how it turns pixels into decisions, see the real-world numbers, then talk about scaling up. And finally, we'll tackle the really important trade-offs that come with all this progress. All right. First up, let's really dig into the root of the issue, the rigid, inflexible nature of our old-school traffic signals. In a world that's changing by the second, they just can't keep up. Here's the thing. The vast majority of traffic lights out there are running on simple, preset timers. They have no idea if there are 100 cars waiting or none at all. They're completely blind to what's actually happening. And that blindness is a massive source of needless waiting, especially in what researchers call undisciplined traffic environments. Think of a place like Karachi, Pakistan, where the study was done, with a wild mix of vehicle types and very little lane discipline. But what if our infrastructure could actually see? What if it could think and react in real time? Well, that's exactly where AI comes in, giving our intersections a desperately needed intelligence boost. Now, at the heart of all of this is a technology with a fantastic name, YOLO, which stands for You Only Look Once. See, unlike older models that had to scan an image multiple times, YOLO gets it all in one single pass. And why does that matter? Speed. It's so incredibly fast that it can process live video feeds without ever falling behind, which is absolutely crucial if you're trying to manage traffic as it's happening. The other key piece of this puzzle is something called edge computing. Okay, so instead of sending huge video files all the way to some distant cloud server and then waiting for instructions, all the thinking happens right there, at the intersection. It's like giving each traffic light its very own brain. This completely slashes delays and makes the system super reliable, allowing for instant, on-the-spot decisions. So we've got the eyes with YOLO, and we've got the brain with edge computing. But how do they actually work together to change the lights? Let's walk through that journey, from pixels on a screen to pavement in the real world. It's really a pretty logical four-step process. First up, YOLO scans the camera feed, identifying every single car, bus, and motorcycle. Then, and this is clever, it calculates the traffic density using something called passenger car equivalent, or PC. We'll touch on that in just a second. Third, an algorithm takes that real-time data and dynamically adjusts the light timing. And finally, there's a fairness mechanism built in to prevent what's called starvation. That's when a lane with just a little traffic gets stuck waiting forever. This makes sure everyone gets their turn. Okay, so this passenger car equivalent idea is just brilliant. The system doesn't just count vehicles. It actually understands how much space they take up. So a car is the baseline, a 1.0. A smaller motorcycle is just half of that. But a big bus? That's like 2.5 cars taking up space. This weighting system gives a way more accurate picture of how jammed a lane really is, which of course leads to much smarter decisions. Now, this all sounds fantastic in theory, right? But the billion-dollar question is, does it actually work in the real world? What's the practical impact? Let's look at the numbers. Here it is, the headline number. That study in Karachi, using this exact system, found it could slash congestion at an intersection by up to 33%. Just stop and think about that. Imagine your wait time at that one terrible intersection on your commute getting cut by a third. That's not just a little bit of time back in your day. That's less fuel burned, less pollution coughed into the air. It's a real, tangible impact. Okay, so fixing one intersection is a huge win. But the real game changer is when you start connecting them all into a network. This is where we go from a local fix to a true citywide solution. So let's jump over to another case study, this one from Seattle. Here, researchers set up a network of 16 cameras along the super busy I-5 freeway. We're talking about a whole different level of complexity compared to a single intersection. Now, the single biggest challenge when you have a bunch of cameras is something called vehicle re-identification. Basically, can the AI figure out that the blue SUV seen by one camera is the exact same blue SUV that another camera sees a few hundred feet down the road, even with different angles or lighting? Well, as you can see with cars number 17, 16, and 21, yes, it can. It successfully tracks individual vehicles as they move through the entire system. And because it can track specific cars, the system can calculate incredibly accurate, real-time data for the whole highway. Just look at this chart. The yellow line is the AI's estimate of travel time, and the green line is the actual, true result. They're practically on top of each other. This proves the system isn't just making a wild guess. It's providing rock-solid data that traffic managers can use to control flow across an entire freeway. So, this technology is clearly powerful. It's incredibly effective. But there's always a but, isn't there? We absolutely have to talk about the other side of this coin, and that is privacy. A big analysis of AI privacy incidents found that AI doesn't always create brand new risks, but it pours gasoline on existing ones. Those same cameras making traffic smoother could be used for widespread surveillance. Data that was collected for a traffic study could be sold or repurposed for commercial use without anyone's consent, and huge amounts of what seems like anonymous data can be pieced together to figure out very personal things about us. And this quote from the researchers really nails it. They're saying that adding AI isn't just another feature, it fundamentally changes the privacy conversation. The technology is so powerful that it demands a whole new level of caution and a serious debate about what we as a society are willing to accept. Which brings us right to the final question. And believe me, there is no easy answer here. The promise of a smarter, faster, safer commute is incredibly tempting, but it forces us all to face a pretty fundamental trade-off. As this technology continues to roll out onto more and more of our streets, we all have to ask ourselves, how much are we really willing to give up for it? What's the right balance?